A quick recap of where we left off in the last video. So after running the solver, we have an answer that the maximum profit we can make given our resources by making lawnmowers is apparently 55,000, which is in our green cell, the objective function. And the yellow cells are telling us that it is optimal for us to make 25 normal lawnmowers and sell them at $600 a piece, and make 50 racing lawnmowers and sell them at $800 a piece to reach our maximum profit given the limited resources we had. Now this solution is answering a lot more questions about our lawnmower problem than only how much to make and how much profit we're going to earn as a result. So I'm going to go ahead and start making some notes, and I would encourage you to do that with me. So when you go back and look at this problem, it will be easy for you to know what's going on. So some important information on this particular screen is my per unit profit earned. And my per unit profit earned for normal lawnmowers is 600. So in order to make little notes, I'm going to be using my review tab, and I'm going to add a little comment right here. I'm going to say, to remember it, this is my per unit profit earned for normal lawnmower. And similarly, this is my per unit profit earned for racing lawnmowers. The good thing about these comments is I can move them around, I can hide them by using this little option, show hide comment, and they just stay there as long as I want to keep them. And finally, this 55,000 is very important information. This is my total profit I am making as a result. Right? Now let's move on to sensitivity report. The sensitivity reports usually are, you will see, are like black and white, and they will have two tables. One will always say variable cells, and other one is always going to say constraints. We're going to start interpreting them. Now, a lot of information that you see over here is coming from your main sheet where you set up and ran the problem. So first, let's start by identifying it. I'm going to start with the first table, which is the variable cells. So this final value that you see is basically the same as your changing variable cells right here. So in order to make a comparison between the two sheets, I'm going to use the same color coding. It's always easy to identify it. So this final value is basically my changing variable cells, that the number of product that I have to make per product category in order to maximize my profit. This objective coefficient is your per unit profit that we were making for each type of lawnmower, which we placed, we didn't give a color to it, but we used it in order to calculate our total profit. So I'm going to give this a green color for consistency. Now always remember that objective coefficient is another name for your per unit profit, or the price you're charging for your product, and the final value is another name for how much product you are actually making for each product type. So these keywords, you have to remember them in order to interpret the sensitivity report. Now this allowable increase and allowable decrease are actually important information, because it actually tells us that as you can see, as you can tell, if you go into the market, there are several manufacturers that are selling same kind of product. Like if you go into the market, you will have lawnmowers made by company X, company Y, and company Z, and you'll see they'll have price variability. So that price variability actually is, they just don't come up with the price all of a sudden. That's a very sound decision that they make after analyzing many variables. Allowable increase is one of those insights, or one of those variables that we look at in order to decide how much more, how much less we can charge for our product. Now remember, this yellow cells are final value. It is not very easy to change these values for a manufacturing plant, because the cost of changing these values trickle down and result into a lot of variable and fixed cost implications. So we try not to disrupt these values unless there's absolutely need. So let's say if your product is high in demand and you think that you can charge more for that product, but you also don't want to change the final value. How would you know how much more you can charge for your product? Well, you look at your allowable increase. So your allowable increase basically is how much more you can charge for your particular product without changing your decision variable or the final value. How would we know how much more we can charge? Let's go ahead and adjust allowable increase for objective with objective coefficient. And I'm going to add another column here. I'm going to call it the maximum profit I can charge for my normal lawnmowers. I'm looking at my normal lawnmowers. All I have to do is take my objective coefficient and add my allowable increase to it. So apparently I can charge up to $800 for normal lawnmowers. I will still end up making 25, and I can increase my profit that way. Okay. Same for the racing lawnmowers. I'll take the objective coefficient and I'm going to add the allowable increase to it. So I can charge up to $900 per racing lawnmower without changing the final value of the decision variable. Okay. So let's write this down. What is allowable increase? So the allowable increase, this is the allowable increase in per unit profit of normal lawnmowers without changing the decision variables. I would encourage you to go ahead and test it, change the per unit price for normal lawnmowers, and rerun your solver, and you will see that your yellow cells will not change. Now, allowable decrease is the other side of the picture. It is how much less you can charge for your product without changing your final value. Now, this is critical information when you are thinking about giving discounts to your special customers or to your customers. And I'm going to add another column here. I'm going to call it minimum profit. And to calculate the minimum profit, I'm going to take my objective coefficient because we are talking about changing in prices, increase or decrease. So objective coefficient is what I'm looking for. And I'm going to adjust it for allowable decrease by subtracting the allowable decrease from it. This distinction is very important. To calculate maximum profit, you add allowable increase to the objective coefficient, and to calculate minimum profit, you subtract allowable decrease from the objective coefficient. So I can give a discount up to, or I can charge up to $533 for normal lawnmowers, and it will not change the final value of my normal lawnmowers. And I'm just going to go ahead and copy this. And I can give a discount up to $200 right here. So I can charge as less as $600 for my racing lawnmowers, and it is not going to change the final value for my product mix. So let's write this down. So my allowable decrease is, this is the allowable decrease in per unit profit of normal / racing lawnmowers without changing the decision variables. And I am not only talking about normal lawnmowers here for allowable increase, I'm going to add racing as well. Okay. So to make sure that we added these separately, I'm going to give them an orange color. That's where I look at to make a decision how much more and less I can charge for my product. Okay. So let's come down to our constraints and see what story are they telling. Just like the first variable cells table, constraints table is also importing some information from your main sheet. As you can see right here, for our constraints, we had blue cells, the left-hand side of the constraints, and the red cells, the right-hand side of the constraints. So the blue cells right here, which is the actual number of constraints that we ended up using for this solution, is depicted in the final value right here. So the left-hand side of the constraint is blue, and the red, or the actual number of resources or constraints we have, is right here, and it actually says right-hand side of the constraints. So I'm going to go ahead and color it red. Let me use the red text so it's easier to see. All right. Now, shadow price is additional information that we are getting, and shadow price tells us the implications of changing our constraints on our final objective function, which is the total profit. You will see shadow price. You will see two things about shadow price. The first thing is some constraints have positive shadow price while others don't. And secondly, that you have to determine how to interpret a positive shadow price. First, I'm going to start with color coding it so you know what I'm talking about while I'm pointing at something. And as I said before, the shadow price is, and let me write this down. The shadow price is your increase in objective function, which in this case is your total profit due to marginal change in the constraint. All right, so let's talk about each constraint. So we have a shadow price of 200 for engines, 20 for labor, and 0 for tubing. The first thing to notice is that if you compare your right-hand side and the left-hand side of your constraint, if the right-hand side and the left-hand side of the constraint are equal, you will probably or likely will have a positive shadow price. Not always, but likely. And the contrast, if you see for tubing, we are actually using 1,300 square foot of tubing, and we have on hand 3,000 square foot of tubing, so we are using less of this resource, so we have a shadow price of 0. The implication is that there will be no use of adding more tubing to this resource because we are already underutilizing that resource. Only those resources that we are using to their maximum may have a potential to benefit us if we increase it in number. So let's interpret the $200 shadow price for total engine. So this 200 means that if we increase the engine by 1 unit, that is right now we have 75 engines and we are using 75 engines in our manufacturing process. If we have to increase our 75 engines to 76 engines, this shadow price is saying that our total profit is going to increase by $200. Similarly, if we increase our engines from 75 to 77, our total profit is going to increase by $400 and so forth. So let's write this down. So this is 200 shadow price is telling us that if we increase the engine by 1 unit, which is 1 engine, the total profit will increase by the shadow price, which is $200. All right. Now I'm going to go ahead and quickly test that. So right now we are at 75. I'm going to click it to 76. I'm going to go into my solver, solve it, and there you have it. So we end up, so our profit is increased from 55,000 to 55,200. All right, I'm going to revert it back. Okay, so let's talk about this 20 shadow price. So what is this telling us? So while I'm talking about it, I'm going to also make a little note. So this 20 is telling us that if we increase the labor hour by 1 unit, which is 1 labor hour, the total profit will increase by $20. Right now we have 2,000 labor hours. We are using 2,000 labor hours. So if we have to increase from 2000 to 2001, we're going to have a $20 increase or total profit. Finally, zero shadow price means if we increase our tubing by 1 unit, it's going to have no effect on our total profit. Now the question right here is, and I would like to ask regarding labor hours, it has to do with how to interpret the units, and it's very important to keep a track of. The question that I'm going to pose to you is, in order to, if we have a choice to increase our resources either by 1 engine or by hiring 1 person, and we have to make a choice, we can't do both, which one is better? So in other words, should we increase 1 engine or hire 1 person? So if you look at the shadow price, 200 looks much bigger than 20, and you must be thinking that, well, yes, it's better to just get 1 engine. We're going to have an increase for $200. But remember, you can't just hire, typically you just can't increase your resource, your labor resource in terms of like 1 hour. So when you commit to a person, when you hire a person, you have to, the typical assumption is that you're hiring them for 40 hours a week at the least, right? And unless specified otherwise. So if you look at that, if you're hiring a person, the implication is that they'll be working 40 hours a week, and 40 times 20, it's going to probably end up in an $800 increase in your profit. So that looks more promising than a $200 increase. So looking at this, as I specified before, if you hire 1 person, that's going to be working for you for at least 40 hours a week, multiplied by the shadow price is like $20 increase per additional hour, which will result in total of 800 in total profit as compared to 200. And let me just make a comparison right here versus 1 engine increase is going to give you a total of $200 in total profit. Now once you have this information in front of you, it becomes easier for you to decide whether to hire 1 person or 1 engine. Now with that being said, hopefully that now you can interpret your sensitivity report, and please review your notes and review it before coming to class.